It is a task carried out by OS and hardware to accumulate multiple processes in a main memory. Means what happens here? Suppose there are more than one process. So how to allocate the memory to these processes, that is specified by the operating system. If only a few processes can be kept in the main memory, then much of the time all processes will be waiting for IO and CPU will be idle. Means now listen here, suppose you are having P1, P2 and P3 process, and if you have placed only P1 in the main memory and P2 and P3 are in a secondary memory, so P3 and P2 will continuously check whether the IO and CPU is free or not. So more time will be in this checking whether CPU or your IO is free. In this case, what happens? Sometimes a process P1 will finish the execution and it will be in a main memory, but P2 wants to come into the main memory. So what happens here? At that time, your CPU and your IO will be idle. Means what happens here? It will be CPU will be idle. It is not doing any work. So for that purpose, which process should be there in a main memory and which should be in a secondary memory? For that purpose, we require the memory management. Hence, memory needs to be allocated efficiently in order to pack as many as processes into memory as possible. As you know, IO operations are faster than the memory. So the IO and CPU should not be idle. We have to specify which process should be in a main memory. So that is done by the operating system. In most scheme, the kernel occupies some fixed portion of main memory and the rest is shared by the multiple processes. So kernel requires some main memory and the remaining part will be allocated by the processes. Now next point is so that is why we have to specify why we require the memory management. Actually, unit number 4, memory management. Need is what? Which process should be in a primary memory? So which is a primary memory? RAM is your primary memory. Hard disk is your secondary memory. So which process should be allocated in a primary memory? That for that purpose we require the memory management. Now second point is a memory management requirement. So there are the 4 requirements of memory management. 5 requirement: relocation, sharing, protection, physical memory, and logical memory. So these are the 5 requirements of memory management required. So first one is your relocation. So as the name specifies, relocation, programmer cannot know where the program in memory when it is executing. So what happens here? Suppose I am a programmer. So at which location the program is placed, that is not known by the programmer. So programmer cannot know the program will be placed in memory when it is executed. A process may be often relocated in main memory due to swapping. What happens here? Swapping means what? Calling that program from secondary memory to the primary memory. This is called as a swapping. And again, after execution, you are placing that memory, that program into the secondary memory from a primary memory. That is called as a swap out. Swap in, getting the process, and swap out, again storing that process to the secondary memory. A process may be relocated in main memory due to swapping. So when you are calling that process, where the process is located, where that process is stored is not known after execution. So that is called relocated. Swapping enables the OS to have a larger pool to ready to execute the processes. So what happens is swapping will allocate, or swapping will allow the process to allocate the memory after execution of that process. So this is relocation of that process. Memory reference in code for both instruction and data must be translated to actual physical memory address. So in microprocessor, you have studied how the address conversion physical logical address into the physical address. So this is also required in operating system. So memory reference in code must be translated to actual physical memory address. So whichever address, logical address, we have to convert into the physical address. After the execution, again place the logical address. That is a relocation. Then second requirement of memory management is your protection. Means in protection, what happens? No process should intersect or we can say that allocate the memory of another process. So for that purpose, protection is required. Processes should not be able to reference memory location in another process without permission. However, this point means first process should not intersect with the second process without permission of that process of intersecting the memory of another process. Impossible to check addresses at compile time in a program since program could be relocated. Address reference must be checked at runtime by the hardware. So that is duty of hardware. Or address reference of the process should not intersect with the another process. For that purpose, we require the protection. So that is the second requirement of memory management. First one is your relocation. Second one is your protection. Third one is your sharing. So what happens in sharing? Now in this, if the process want to share the memory, two process want to share the memory, at that time also we have to specify some protocols regarding to the sharing. Must allow several processes to access a common portion of main memory without compromising the protection. Without compromising the protection. Cooperating processes may need to share access to same data structure. So whichever two processes are executing simultaneously, if they are sharing the data, at that time there must be proper cooperation between the processes. Okay, better to allow each process to access the same copy of program rather than have their own separate copy. So this will allow what sharing of the resource of the processes in a memory. So this is the third one, sharing. Then fourth one is your logical organization. So logical organization, users write program in a module with different characteristics. Instruction modules are exactly execute only. Data modules are either read only or read write. Some modules are private, other are public. So to effectively deal with user program, the OS and hardware should support the basic form of module to provide the required protection and sharing. Now what happens in this also? For that purpose, you have to study what? Paging and paging and segmentation. So in this what we are doing conversion of logical address into the physical address. So in logical organization, user writes program in module with different features or characteristics. Instruction modules are only what? Execute only. Instruction module. So instruction set are only what? Execute. Data modules, actual data are read only or write. Some modules may be private, others may be public. So how to specify this module, convert this module, what types of rights should be given to this module, that is specified in a logical organization. To effectively deal with user program, the OS and hardware should support the basic form of modules to provide the required protection and sharing. And last one is your physical organization. Physical organization. Now in this, actually we are storing on a secondary memory. In physical logical organization, what we are doing, combining the CPU address, CPU and your base address, we are combining and finding the location. In this, we are going for the physical memory organization or physical secondary disk storage. So secondary memory is a long-term store for the programs and data, while main memory holds program and data currently in use. Okay, so whichever program is currently executing, that will be in a primary memory. But in secondary memory, you are storing a large amount of data. Now, if you want to move this primary data from primary memory to secondary memory. So moving information between these two levels of memory is a major concern in memory organization. So actually we are storing the data on a physical disk, or that is called as a physical organization. It is highly inefficient to leave this responsibility to the application programmer. So how we will store this into the secondary memory that is specified by the physical organization. Okay. काय अडचण आहे या पॉइंट मध्ये? काय अडचण आहे इथपर्यंत? So this is a memory introduction to memory management. What is memory management and requirement of memory management? So in that there are 5 requirements: sharing, protection, relocation, physical organization, and logical organization. Then next point is a simply memory management that will conclude that will start in the next lecture. Okay. सगळे मुलांना जॉईन व्हायला सांगा उद्या 11:15. चौधरी, गायकवाड, कुलकर्णी, 11:15 सगळ्यांना जॉईन व्हायला सांगा. आहेत ना मोरे? हा, उद्या 11:15 हा पॉइंट चालू करू आपण आता. Simple memory management. So it is simple one: fixed partition, dynamic partition, simple paging, and simple segmentation, and one is a buddy system. So this is simple theoretical. So we'll study this in the next lecture. उद्या मला 40 मुलं पाहिजे लेक्चरला. आलं एक लक्षात? मोरे, गोडसे, शिंदे प्रतीक, गायकवाड, सीमा जाधव, सोनाली कवडे, बघ तुमची अटेंडन्स लागली. सगळ्यांना सांगा उद्या जॉईन व्हायला.
ओके सर.
हो सर.